How are arithmetic progressions linked to triangular numbers? Imagine stacking dots to form perfect triangles. Each layer adds more dots, creating a pattern that grows in a special way. This visual idea connects numbers and shapes in a fascinating way. Triangular numbers are the total dots needed to make these triangles. The first triangular number is just 1 dot. The second is 3 dots, which form a triangle with 2 rows. The third is 6 dots, with 3 rows, and so on. The formula for the nth triangular number is the number of dots in the triangle with n rows, which is n times n plus 1 divided by 2. So, the third triangular number is 3 times 4 divided by 2, giving 6 dots. Now, an arithmetic progression is a sequence of numbers where each number is found by adding the same amount to the previous one. For example, 2, 4, 6, 8 is an arithmetic progression with a common difference of 2. Here's where the connection begins. The sequence of natural numbers 1, 2, 3, 4, and so on is itself an arithmetic progression with a difference of 1. If you add up the first few natural numbers, you get the triangular numbers. For example, 1 plus 2 equals 3, which is the second triangular number. 1 plus 2 plus 3 equals 6, the third triangular number. This shows that triangular numbers are just the sums of the first n numbers in an arithmetic progression. Another interesting link is that some triangular numbers themselves form arithmetic progressions. For example, if you look at certain triangular numbers, like T2, T4, and T6, they form a sequence where each term increases by a fixed amount. This pattern reveals how triangular numbers can be spaced evenly in certain cases, creating their own arithmetic progressions. There's also a neat fact that when you add to consecutive triangular numbers, you get a perfect square. For example, T3 plus T2 equals 9, which is 3 squared. This shows a direct link between triangular numbers, squares, and arithmetic progressions, because the sum of two sequential figures in the series results in a perfect square. From a counting perspective, triangular numbers tell us how many pairs can be made from a set of objects. If you have 5 objects, the number of pairs you can form is a triangular number. This counting process is related to the sum of an arithmetic progression of numbers, showing how these sequences help us understand combinations and arrangements. So, in simple terms, triangular numbers are created by adding up the numbers in an arithmetic progression. And some triangular numbers themselves from new arithmetic progressions, revealing a beautiful pattern in how numbers grow and relate to each other. This connection helps us see the order and structure behind many different types of number sequences and shapes.